case, I'm what's known as the industry warm-up act after a nice lunch, so I'll try and keep this light and moving reasonably swiftly. So I'm just going to reflect a little bit on the challenge of insecticide resistance from an industry perspective, and just to give you a flavour of that, if I can work out this thing. So the first question is, what is IRAC? In 2003, I lived in the US, and I said to my neighbours I was going to an IRAC meeting, and I had to explain, no, not that IRAC. This is a different IRAC, but it does sound very similar. So what is IRAC? IRAC is 13 companies actually belong to IRAC. It's the Insecticide Resistance Action Committee. We have an international group which covers crop protection, plant biotechnology, and public health. There's a number of country groups, and there's also a number of working groups as well. There is some material that I left out earlier yesterday. If people want material, just give me a shout and I can pass that sort of material on, which has all this information in. Just this is to remind me, there are other RACs as well, Resistant Action Committees. There's the HRAC, which is the herbicide, and there's FRAC. You can even have fracking, the Fungicide Resistance Action Committee. So just not insecticides. So this IRAC was formed in 1984, and it's still growing. It's in its 32nd year now, and it's a specialist technical group for both the ag and public health, our industry. It's part of CropLife International, and the key thing, it provides a sort of coordinated industry approach to try and help manage resistance in insects and also in mites. And critically, it does promote the development and facilitates the implementation of these IRM strategies. We have communication tools, literatures, outreach programs, educational programs. We hosted a workshop in the Philippines on rice growing. So it's a very active organization. We have around 70 industry representatives and specialist members in different working groups, and there's, as I said before, 7 country groups with a further nearly 80 representatives. So there it has. It's grown. In 1992, this was an IRAC meeting, but I was at this 2013 meeting, far more people there, indicative of the growth and success of this organization. The public health team, which deals with vector, of course, there are only 6 companies represented out of the 13. I'll try and explain that a little bit as we go on. And we have representatives from Syngenta, BASF, Dow, and Bayer, Sumitomo, my own company, and Vestergaard. We also have non-industry observers from IBCC, and also Alan Porter, who is our consultant who tries to pull all this activity together. So what are our activities in the public health sphere? We get involved in a lot of different activities, working closely with WHO and Raman, wherever he is. We work closely with him and Rajpal on a number of initiatives, including guideline setting. We're very active members of the RBM Vector Control Working Group. We're also very active, for some of you may not know, but there's a reform process in WHO going on called I2I. We're involved in that. And there's a working party which is involved in updating test procedures. And also, of course, we interface with many of you people here in the academic institutes. Now, we've talked a lot about this, but this is just an interesting graph just to show that resistance does develop. We know that. And this slide shows the resistance in the first 14 years following launch from a range of insecticides, and it's a pretty nasty looking picture. And this is really what we're trying to avoid. We're trying to flatten this line to manage it, to reduce it, and to minimize this spread of resistance. This is motherhood and apple pie to this audience, but of course we have resistance in many vectors, including vectors of arboviruses. This is quite an interesting one. I organized a literature search recently, and any papers with insecticide resistance in mosquitoes. And this huge upsurge is a reflection of many things. One is, of course, increased resistance, but also increased academic interest in resistance, and increased concern with the resistance, and of course increased funding. So, I mean, that's like an exponential curve. It's pretty interesting, but also pretty concerning. So, resistance management, of course, we talked today and yesterday about rotations, mosaics, and mixtures. And Isabel, of course, talked very nicely yesterday about the OCP program, about the program in the Cameroon, and also the Mexico, which was actually an IRAC-funded program, the Mexico program looking at different strategies. And this is all part of the IRAC program. It's also in the GPERM, Global Program for Insecticide Resistance Management from WHO. But it does imply that you have multiple effective insecticides with different modes of action. So specific challenges affecting our business, and we've heard this a bit yesterday, for example, the New Caledonia, the removal of malathion. We have challenges because we don't have many chemistries, and I just want to explore that a little bit going forward. So first of all, there are fewer companies involved in developing any insecticides or crop protection products. And this is a pretty dramatic linear decline, and anyone with a ruler could pretty quickly see that by 2020 we might have no companies. Hopefully it doesn't flat line like that, but it doesn't look very encouraging. Fewer and fewer and fewer and fewer companies involved. And the company I work for, well, multiple companies I work for have all disappeared now, and I'm the sort of survivor. I'm a bit of a relic, a fossil perhaps, surviving all those companies prior to mine that I now work for. And it's also much harder to discover insecticides because in some respects all the easy ones have been found. And there's other reasons as well, regulatory reasons, that the hurdles, the safety hurdles are much higher. But this is the success rate, the number of compounds that need to be screened for each product found. So in the old days, you'd look at 1,000 compounds and come and find one that could go to market. Now you're having to look at tens of thousands of compounds. So that, of course, triggers cost. And with the increased regulatory hurdles and harder to find modes of action chemistry, costs have gone up. And this is for the whole ag business, not just for vector, but it trickles into vector. So I don't want to get into huge detail, but this is just a chart primarily to remind me that the costs really are there in the chemistry, biology, tox, and environmental. Developing E-Fate packages is incredibly expensive. Doing all the tox, GLP studies is incredibly expensive. And in the ag area, you could looking at over 250 million US dollars to develop a single new AI. In vector, it's potential to be less because you have a commuted requirement on your data package, but it's still a significant spend. Significant spend, estimated maybe at $80 million to develop a new AI, bring it into the marketplace just for vector. So one of the issues, and we mentioned this briefly yesterday, vector control is a very small market, but similar development costs. Even if they're half the cost of ag, they are still significant. And in crop, and this is a little bit of old data, but this is 400, let's say 50 billion US is the market size for crop. If you add in maybe 5 billion for turf, amenity, all the sort of non-crop area, what is vector? How big is vector in that? It's tiny, it's widdly, it's hardly worth putting on a graph. It's maybe a billion, it's possibly less than a billion, but it's certainly in that zone. So a billion out of, say, 50 billion is 2%. It's not a huge market, but it has very similar development costs. And as a result of that, vector control insecticides typically are repurposed ag products. And I think we all know that, but this just needs restating to remind ourselves. Most of the vector control insecticides we have trickle down from ag. I put this in a little bit, it's like a reverse family tree a bit, everyone dying out. This is consolidation of the industry. 5 of the top companies representing 73% of the ag market, and it's only getting worse. I did notice, and you'll realize how I'm not so pushing Sumitomo here, because Sumitomo is not even on here, partly because Sumitomo has survived and has a single line. It hasn't yet been a result of a merger or acquisition. But in 2016, many of you are familiar with this, but Dow and DuPont have merged or are merging. Bayer Monsanto acquisition is happening, and Chem China have acquired Syngenta. So that's just 1 year. So this carries that slope on down, fewer and fewer companies involved in vector control. So we saw this slide yesterday. This is the mode of action classification that IRAC put out, and there's a little booklet here with this in. This can be downloaded off the website, and there are posters available if people wanted to speak to me. But when you look at that, there are 29 different mode of action insecticides available. Superb, fantastic. But partly because of all the reasons of cost and getting to the market and things, only 6 of those are mode of actions are used in vector control. And of course, we know what they are. But one of the reasons for that is the target product profile for vector is different from ag. So ag tends not to want really long residual compounds. whereas we do tend to, in vector, want those, particularly for IRS and bed nets and things that hang around for a long time. Also, the ag targets are butterflies, Lepidoptera, and beetles, which have a very different mode of action and target sites to mosquitoes. So it's generally a thing that kills a butterfly well doesn't always kill a mosquito very well. So what do we have? We've got carbamates and OPs in our list, pyrethroids, DDT. Of course, both of those groups are very resisted now. We've got the spinosins, and we'll hear a little bit from Bill, Janie, from Clark on that later. We have the juvenile hormone mimics. Amongst them is methoprene and also pyriproxyfen that Sumitomo manufacture. We have chitin synthesis inhibitors, divalent diflubenzuron. And you have BTIBS, and we have Peter Chand here from VBC, and they manufacture a good range of very good, highly active products like Vectorlex and Vectorbac. We have a few others coming, which is nice. So down here, and you probably can't see a little yellow line, but down here we have clothianidin, which is a neonicotinoid, and Bayer are bringing a neonic IRS into the market, and Sumitomo are actually into the mosquito control market. In the next couple of years. And also, Bayer are also bringing in a butenolide, which is also a group 4 chemistry. It's not a neonic, but it sits in that same box there. And then also we have chlorphenapir, which BASF is bringing into the market in Interceptor G2, and possibly also an IRS product. So there are a few others coming, but we have Julian Entwistle talking a little bit later about the IVCC pipeline, and this is where Gates and others are helped try and de-risk the entry costs for companies to bring compounds into the public health market. I don't want to, wherever you, there you are, Julian, I don't want to steal your thunder here, so I'll leave that for Julian to talk about some of those things. But there is some glimmer of hope on the horizon. But, you know, in simple summary, there are incredibly limited options in our toolbox. Insecticide should not be the only intervention to be considered, and we really need to think about IVM. And Anne, of course, yesterday talked very nicely about IVM, and Raman mentioned it too in his presentation about, you know, looking at what I call the 3 S's, but I could really only think of 2. But this is screening and sanitation and also waste management. Some of those aspects, particularly for ADs, is very important. So IRAC really push that we should be doing those things as well as using insecticides. IRAC's not all about let's use lots of insecticides. It's looking at the whole package, the whole picture. And the key message is really we need to maintain susceptibility wherever possible and before resistance develops, and be proactive and not reactive. And I'm afraid a lot of our conversations in the last couple of days, we have seemed to be a bit, you know, if we're reactive at all, you know, we're talking about 4,000-fold resistance in that wonderful data in China, the CDC data, but often we're still using the same products. We're quite constrained in that sense because of this limitation. So in the booklet here, we put together a very nice little flow chart, and this is a bit motherhood and apple pie, but it's worth just going through a little bit. It starts off, you know, how do I prevent or delay the onset of insecticide resistance? Well, obviously we do baseline studies, CDC or WHO test kits, check susceptibility. If you have little or no change in susceptibility, that's great, but what should we do? Well, we shouldn't just carry on doing what we've done in the past, because we really should rotate to an alternative mode of action chemistry, if possible, before we have a problem. That's being truly proactive, not reactive. If you have a small increase in survivors, well, you obviously need to increase your monitoring and, again, rotate. If you have a very high level of survivors in your test and you get the red lights all flashing and you really have got some indication of resistance, then, of course, we have to conduct further tests. And go the wrong way on the slide. Where possible, undertake assays and evaluate susceptibility. Now, this line continues on to the next chart. So if you have a really bad problem and your existing insecticide class is resisted, but all other classes are effective, then you change. If other classes of insecticides are also resisted, choose a class which is not. But if all classes are resisted, I mean, that's where we are with a lot of, right here and now today, this is where we are. All classes are resisted. We are in that situation with bed nets at the moment. Pyrethroids are used exclusively on bed nets, and they're all resisted. But we should use an MOA class that still provides the best control. So choosing out of those MOAs the one that still works best, even though it's resisted. But ensure IVM is used, and that really should be sitting in these other boxes as well. And include larvicides. Peter? include larvicides, with different modes of action to adulticides. Don't here, and it would be a big mistake in my mind, don't here use a larvicide with the same mode of action to an adulticide. So in the case of tenofos, which is an OP, you shouldn't really be using an OP as an adulticide as well. You should really be thinking about that in the big picture. So I don't want to go into too much detail. There's a lot of words in here, and I'm sure my time is running out. I'm getting a nod here, so it obviously is. But you look at the booklet, and you'll see also what do you do, product failure, determining the cause. Well, what do you do if the product does not seem to work? Well, why do you suspect this? Have you got resistance? Yes. Resistance? No. Well, this is a very important thing. It was mentioned yesterday as well. If you don't have resistance indicated, well, you know, have you done the correct dilution rate? Have you done the correct application rate? Is the product within date? Is it stable? And all those things. Have you got the right QA documentation? Was the good quality Hoope's recommended product used? Have you used quality products? And if the answer is yes, you're using all the right products, then the next option is to, and this is so much detail, you can look in the booklet, but is basically all about has the machine been calibrated for space sprays, indoor residual sprays, larvicides, all of those things, looking at areas where you still might have be able to resolve the issue. So without further ado, I want to thank you very much, obrigado, for being able to come here and present on behalf of IRAC. This is not a Sumitomo presentation, this is an IRAC presentation. There's further details on the website. There is this whole list of literature, a really nice mode of action poster if people are interested in that, and speak to me afterwards if you want any follow-up. Thank you.